So what we're going to cover today is a more accurate rational approximation of our irrational numbers. As you'll remember from the last lesson, we stopped at coming out with a whole number, but that's not really good enough because that's not as accurate as we want to be. So what we're going to do today is figure out how to get a more accurate by extending decimal values for these irrational numbers. Now, if you do this little exercise where you were to draw a 1 by 1 right triangle, okay, 1 inch by 1 inch, you know the Pythagorean theorem, which we've done a little bit about with, and we're going to actually do more in the next unit, is a squared plus b squared equals c squared. So it's 1 squared plus 1 squared equals c squared. So 1 plus 1 is c squared. That means c is the square root of 2. Well, we know the square root of 2 is an irrational number because it's not a perfect square. But we know we can measure this length. And yes, we could use a ruler and measure it out, and we would get something like approximately 1 and 6/16 or 1 and 0.375. But again, it's only a rational approximation. It's not a completely 100% accurate number. But it leads us to the following conclusion. And the conclusion is that all irrational numbers have a decimal representation on the number line. Okay. Now, we're going to use the following tables to help us do this. And what we're attempting to do, it's a little hard to see because my tables aren't separated out like yours are, but that's okay. All right. These tables, as you'll see in your note sheet, are broken into 3 groups. My orientation's now already a little bit off. Okay. Let me just reorient. All right. So we're breaking this table down into the 3 parts that you have on your note sheet. And what we're trying to do is we're trying to find between what 2 numbers does the square root of 2 lie. Okay? So if you look at this table, x squared is the number that we want to, or the column we want to focus on. All right? Because what we're looking for is the number when squared that's closest to 2. Well, you'll see that it's between these 2 numbers, 1.96 and 2.25. So the square root of 2 is somewhere between 1.4 and 1.5, which is why we then start and go to there. So all we're doing is we know the square root of 2, we go from 1 to 2. These are all those numbers squared. Okay? So we're looking in here in my blue box where the number 2 lies between. Now I'm going to go to the next x squared column in red, and I want to see where does that lie between, and that's between 2 is somewhere between those 2 numbers, which is then why I went to 1.41 to 1.42. And which of these numbers is 2 closest or between? So we know that from the first table, it's between 1.4 and 1.5. Because these are values of x that correspond 2x squared. Okay? Now, when we get even more specific, we can see that the square root of 2 is somewhere between 1.414 and 1.415. Okay? And that is a more accurate way to try to figure out. And the way this would work is this would actually keep going until these continuation of these tables would go on to infinity, to be quite honest, because we know the square root of 2 is an irrational number, which means it's a non-terminating decimal, but it doesn't also repeat. So since it doesn't repeat, I don't know what those numbers are after it until I keep going. Now, we have a second method, which, for lack of a better description, we'll call the division method, to find a rational approximation. So, how do we do that? What we want to do is find the approximate value of the square root of 28. Well, the first thing is we know that the square root of 28 is somewhere between the square root of 25 and the square root of 36, the two perfect squares, one above and one below, which means it's somewhere between 5 and 6. Well, which of these numbers is it closest to? Well, it's the 5, because it's closer to 25 than it is to 36. Now, we did this yesterday. The next steps are what's going to be new. Because now what we're going to do is we want to tack on our decimal part. So the little formula is we want to create a fraction. And the fraction is as follows. The numerator is the difference between 28 and 25 in this example. The radicand, which is the radicand, and the smaller perfect square. And our denominator is the difference between the perfect squares, which in this case is 36 and 25. So our decimal equivalent of 3/8 is the repeating decimal of 0.27. Okay? So that our answer for the rational approximation of the square root of 28 is 5.27 repeating. Now, is that entirely accurate? No. It's a rational approximation. But what's better about it is that it's better than just saying 5, as we would have done yesterday when we just stopped at the whole number.